Hallo, hallo. Hallo, hallo. Hallo, hallo, hallo. Hallo, 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 hallo.
Fondsberatung? Voll entspannt. Anlegen leicht gemacht.
Hi, please, everyone, come to the stage. We're about to start.
While others keep on the mark.
Yeah.
That's the second one thing. Yep. Yep. They're happy. You too? Okay.
We're just waiting for.
Cool. Oh yeah, sorry. Miguel gives the start call, yeah. Bros, sound is on a bit?
Sound is on.
Okay, so also beim Livestream meinst du?
Ja.
Okay. Yeah,
The pressure.
yeah, I talk. Because you need to brief them, yeah?
Yeah. Yeah, just say that we will start soon.
Yep. Hello? Yours works too, right? Yeah. Yeah. Good. So we are just about to start. We just need 5 minutes more. And then we have like our entire jury here. And I think Miguel will also introduce all our jury members. So just take a nice seat because we're going back to back with all the pictures and presentations from all the groups. You can't hear anything? Okay. It's with my mask, I guess, yeah. You ready?
All right, we're ready now. Sorry, guys, to have you waiting. It's actually our fault. We gave the wrong address. Okay, so let's get started with the pitches. Without further ado, let's start with the Corintix challenge. And yeah, let's flow to you. So team one first.
Okay. Hi, everyone. I hope you're able to hear me well. I'm Shibashish, and I will be representing Team 1 in the Currentix Challenge. And we are trying to present to you a model which will help us balance the CO2 emissions and also keep the trade supply risks in check in global rice trade. So rice happens to be our crop because we figured that it's eaten all over the world and huge impact, cultural and social, and therefore also has a very large data set, allows us to build a model that can be scaled to other crops and kind of is a crop independent model. So yeah, but obviously you can imagine that it's difficult to build a simplistic model with such a huge data set. So we break it down and we only take the top 20 percentiles of these countries who contribute to the trade. And they happen to be India, China, and Thailand, Vietnam, and the US. The interesting ones in this list are China and US because they are the only ones where the export and the import is comparable, whereas the others, the export is much, much more than the imports. This makes our model more interesting, as you will see in the next slide, and we'll find out how it works. So we built the most representative trade data. We take the center layer. We have these 5 countries that we showed in the previous slide. We take the countries that they export to. Obviously, these countries are very large in number, so we have to break them down into kind of geopolitical regions, and you can identify them easily, like North America, Latin America, Europe, Southeast Asia, the Pacific. But as I mentioned, China and US are also importing a lot, so we have to find out who they're importing it from. And these are the countries they import from. Both the selection of the countries in the third and in the first layer have been done in the 20 percentile rule. So we always eliminate the ones that don't make a difference to the data set. Exactly. And then we start to build a model that can be scaled and is crop independent. And therefore, we have this objective function, which obviously takes into consideration the CO2 emission, which we are trying to minimize, and the risk index, which we are trying not to influence much or at least reduce in the best case. Exactly. And so the risk index is basically a normalized, it's a normalized variable that includes the readiness, the climate resilience, and the vulnerability of a specific country. On the other hand, the CO2 emission depends on the trade quantity, how much 2 countries are trading, and what's the shipping distance, because that's it's basically the emission. We normalize both of them in order to be able to include them mathematically in the objective function. And these are some of the scores that we use because, obviously you can't include all of them. So we kind of break them down in the form of dimensionless numbers. And we have these gains, these index scores. The first 2 are from websites that we were provided with. And the last one, we made it ourselves with some references. And we have different contributions from different type of transport because land, sea, rail, and air, as you could imagine, contribute very differently to the CO2 emissions. Now I will give it over to Arijit to show you how the model worked eventually.
So now comes the interesting part. So did our model work? Yes, it actually did. So as you can see over here, that these are the top 5 exporters like China, India, Thailand, US, and Vietnam. We can see that US is trading a lot. Like the graph is between the quantity of rice traded and the distance that it travels. And US is trading a lot in terms of quantity as well as the distance. So you can see that there is an anomaly. Like these are all the major Southeast Asian exporters, and this is the US, which is like quite an anomaly. So now now the next part comes. We want to reorganize the trade routes based on the optimization model. So how this could be done? We already told that US also is an importer, and Pakistan happens to be one of the major exporters to the US. So after optimizing it, the initial, the optimization phase was that US was transporting a lot of rice to the Southeast Asian countries like South Korea and Japan. And whereas that could be solved by potentially sending the same amount of rice from China. And Pakistan, which was already in a surplus to send it to the US, can send it to China. And this way the trade could happen, and also the CO2 emissions are reduced. Let's see the numbers now. So this is a graph which can show you the distance which was initially traveled. So this was the initial route that the US would take through the through the Panama Canal and send it to South Korea or Japan. And the trade route we propose is from Karachi, like right down there in Pakistan, to the South China, and then from there to the South Korea. So in order for this model to work, the summation of these two carbon emissions should be lesser than the original route. Also, while not increasing the risk, obviously.
1 minute left.
Yeah, these are the pre-optimization and post-optimization results that and also our recommendations. So pre-optimization, we see that the emissions are 97 kilotons of CO2 equivalent. And post-optimization, we reduce it down to 54 kiloton. This is including both the routes from Pakistan to the China and from China to South Korea. In this way, we also reduce the risk of USA because US can now become self-reliant and it has not to depend on the production from Pakistan, which is like quite far away. So now coming to the impact, we saved 43 kilotons of CO2 with just optimizing one trade route of rice. What does this mean? 1 ton of CO2 in order to be removed from the environment needs 50 trees to be working like continuously for 1 year. So in order to have 43 kilotons of CO2 and just one route of rice from the US to the Southeast Asia, we need 2.1 million trees to work or to function for 1 year.
Time's up. Speed up.
Yep. So that's
Okay,
the
wow,
amount of
great,
impact we
great.
have. And
Great
in
work.
order to have any kind of questions, yeah, we are.
Big applause for team 1. We made it just in 6 minutes. Okay, now we have 2 minutes for questions from the jury members. Do you have any questions?
Thanks a lot for the great presentation and super interesting approach that you chose. Just wanted to ask you, like, what was the biggest challenge for you to find the algorithm for the optimization, like to?
The biggest challenge was to make sense of the data because there was so much data available that we want. Sorry. To make sense of the data because we wanted to really have an algorithmic approach for even selecting what we selected, like rice or eliminating the top 20 percentile and all of this. I think so. The model was like, let's say 1/3 of the time, and the curation of the data and the reduction of the data was 2/3. So I would say, yeah.
If I may add here, I think making the model generalization was the biggest challenge because given the vast varieties of crops we have and the 192 countries data, and you take combination with every 192 pairs, and it's a huge, humongous amount of data to make sense out of that, as he pointed out, and to make the model robust to different changes is what we were focusing at.
Okay, thanks a lot and congratulations. It's great to
so
see
much.
that. Yeah, thanks. Yeah.
Great. Next up, we have team 4. Team 4, you ready? Great. Sorry. Okay, so team 4 prepared. What exactly do you prepare? Presentation plus a demo, which is yeah. Okay, so unfortunately we cannot show the demo because couldn't plan ahead.
Can we show it to
But yes, maybe you can show the jury members on the laptop. Yeah, I think that's fair enough. Okay. So your time starts, Nero.
Give her the mic.
Switch slides by hand. And,
Yeah.
Okay. PDF.
Doesn't matter.
Yeah, she provided.
Presentations stand in the middle to answer.
Okay. Yeah. Yeah.
All right. 6 minutes to go.
Okay.
You can start.
So, thank you, Team 1, for explaining trade optimization to the crowd. And let's try. Our challenge is to show you that our project is just as interesting as theirs. So global agricultural trades, like global trade of agricultural goods, is very complex because it is driven by many strong forces. Some of them are economic, with the supply and demand of individual commodities by different countries, but other are geographic, based on which country can produce what, and political, who is friends with whom. But recently, climate has become an even bigger contributor to that whole trade balance formation. And it's sort of a negative cycle because the more trade we do, the more greenhouse gas emissions we generate, which warms the planet. And when the planet warms, it will increase risk on trade, both on the production side and the transportation side. So to break this negative cycle, we need the collaboration of everyone involved in this trade ecosystem. That means governments, policymakers, companies, and even us consumers. But how do we manage to align such a big crowd of people with diverging interests towards a common goal? And we do this with TradeOpt.
Yes, exactly. You didn't go to next. Yeah, so this is exactly why we built TradeOpt. It's a way for all these players to visualize and truly understand the way they're impacting global trade and climate. And the way, so the way TradeOpt is built is basically on an optimization problem, specifically a multi-objective optimization problem that is composed out of these three main terms, which are weighed according to parameters that can be tuned or tweaked depending on the user. And these are risk, emissions, and price. And the constraint of this minimization problem is to keep the trade balance in equilibrium. So, yeah.
Thank you. So unfortunately, we cannot plug this into the big screen. So I'll show the demo to the jury. Hopefully, some of you can also see that. So I'll get a bit closer. So basically, we built a tool that allows us to. A little bit closer. So we built a tool that allows us to, we can display a model of the world, and we can also select a country that we want to visualize the trades for. So for example, here, we can select the Okay, so now, for example, I inputted that we want to see the trades for a specific commodity, in this instance is sugar, for a specific country. So in here we see, again, the model of the world, and then we see the trades of imports that are represented in green lines and exports that are red lines here. And then we can also select any other country for this specific commodity. We can also look at data for other commodities. And what's really cool is that we also build it in a way that we can set up the initial conditions as they are right now, but in top of that, apply the optimization framework based on the cost function that David was presenting. So now we can here enable optimization. Yeah, and then we see, all right, here. And then we see like small improvements that we can do to the current state of the routes, such that we minimize the cost function that is based in emissions, in climate risk, and in price of commodities. And then we can do, again, this for every specific country. I'm not going to try other countries because we're running short of time. But yeah, this is really a very good tool for visualizing current trade maps, but also improving the trade maps. And here, one thing that I didn't mention is that we can also change here, there are sliders, so we can change the weight that we give on the different elements of the cost function that we want to minimize. So we can focus more on the emissions, we can also focus more on the climate risk part or on the price part, according to what are our needs.
So what you see here is built on past and present data. So the optimization function is using a bunch of tables that are using data from up to 2019. But we wanted to future-proof this tool so that players can use it to plan several years ahead into the future. So what we did for that was we tried to build some heuristics for climate risk based on climate forecasts that are already available. And data that, as example, is already available is, for instance, the maximum temperature in different locations of the Earth, consecutive dry days, consecutive wet days. And based on this, we can come up with a risk heuristic for instance, 2020, but also, in this example, 2070. And this can be done for, we have data up to 2099. Yeah, so that is our project, that is our tool. I hope you enjoyed, and if you have any questions, please ask.
Great. All right, now time for questions. Do you have any?
May we actually play with the tool?
Yeah.
In here, so the commodity is already fixed, so you cannot change the type of commodity because we already pre-downloaded the data set. But in here, you can change the country that you want to look at. So now it was set to the US, but you can really put like Brazil. It's a 3-letter code country, so it has to be uppercase and yeah, 3-letter. Yeah, there we go. So Switzerland is not currently trading a lot, it seems.
For this specific commodity.
Yeah.
Maybe.
Yeah, VRA. All right, there you go. And then what you can do is that, so now the optimization is turned on. Okay. And so this is the result after running the optimization, but you can see how it was before you were running the optimization. So before you run the optimization, it was like that. And then you can enable optimization, and then you see like the improvements that the optimization framework is doing to reduce.
In this case, it's just focusing on emission, although it is on emission, so it's basically cutting down long distance trades. And so the cost function is also defined with the country to itself, which means that if it's for one good, if it's exporting and importing, it will also cut down on some of the exports. And that's what's kind of happening here.
Okay, very cool. Just a question, did you test a bit the sensitivity of the different weights that you put into the cost function? Was there anything that surprised you?
Yeah, we haven't done a lot of work on that. And actually right now, I have to be honest, the toggle for the climate risk, it doesn't seem to have a lot of effect. Okay. Which is not to be expected. Like we expect that if we don't focus on emissions and what we want to mitigate is climate risk, then the results would be very different. So there's something on there that it's not yet like working 100% correctly. But yeah, we played a little bit with the toggles to see how does the optimization change when you focus more on emissions and other things, on price, for example. So yeah, that's. We haven't come up with like a comparative analysis or sensitivity analysis, like to see how it's affected.
Just one day. Okay, cool. Thanks a lot, and congrats to you as well.
Thank you.
Okay.
All right, up next we have Team 7. Please, Team 7, come down. Yes. Up next, after Team 7, we have Team, can you please? Team 8. So get ready here just in case. To speed things up.
Here you go. Thank you. Open PDF. It's the one with the...
Team 8? Where's Team 8? Can you please, well, just get ready. Like, yeah, cool.
Is the black blue thing?
Yes. Exactly.
Guys, always keep a check on this side. Okay.
Hey ladies, hey gentlemen, it's nice to meet you all. And it was a pleasure to hear the other presentations because it's been such beautiful tools for people working together on climate change to do something. But I wanted to ask you a question. Do you really care about climate change? Are you willing to go the extra mile in order to save the planet? No, you aren't, because in this context, you represent customers of Corentex, and therefore you represent companies. And companies care about money, not about making a difference, usually. But what if there was a way, if even you as a greedy company could find a reason to adopt a system to be more environmentally friendly? And this is what we at Corentex Team 7 did. We stayed up all night, we sacrificed our holy night's sleep just in order to get you a tool to optimize your trade routes. And my lovely team member Emma will now tell you how we did that.
Exactly. So how you heard, we set ourselves a bit a different aim than well, of course, still in the aim of the Currentix challenge, meaning how to minimize the risk and the environmental impact of the trade. But we wanted to approach this from the view basically of the customer, of the enterprise that would at the end have to imply this, because otherwise the whole algorithm doesn't bring anything if no one wants to actually do something out of it. And so our main aim was to predict the best route for the enterprise and to make it as simple as possible for this enterprise to choose which route to take. And how we heard, we got an immense amount of data at the beginning, and we first had to find out how to filter this data, and that's why we started clustering the data, and we then took a specific, basically, country and tried the whole algorithm out on this country. And out of this specific, basically, idea, we then generalized, or we could then adapt also that one can use the algorithm on any country. And so here we basically start with the problem of combining sustainability and the risk of the country. And we have these two basically main problems, and so that's why the dynamic programming is basically a great tool to combine this, as it consists of two sub-problems, which one tackles basically separately to then come to the solution of the whole problem. And here we basically started with minimizing first the emissions, looking at the emissions separately, and then at the risk of the different countries to which the enterprise would want to get the products from which. And at the end, our output would be the index of how the ranking would be, how the ranking of the route of trade using to that country would be. So away now from this whole theoretical thing of using the algorithm, we chose Germany basically as a country because it was very having a big impact in our clustering, and we chose an imaginary company in Bremen wanting to import soy products. And we predicted with the past 30 years, well, the data of the past 30 years, we predicted the following 5 years the value of kilogram basically of soya basically that would be imported from those countries. And here you see that these graphs, well, the plotting that we made is choosing basically from every major cluster group one country as a representative. And then we used that data to map basically which countries we would use and the distance to those countries and the emissions that would be needed basically, or that would come up by the transport to those countries. And here you see the basically what happens if we go from Germany, all the emissions that would be needed by shipment or land travel.
Left.
And yeah, then at the end we combined that emissions, the value of the emissions with the value of risk for every country that we would import from. And here you see the mapping of the countries that are most at risk. And in this way, we can adapt basically this algorithm for other countries and predict for the next 5 years, which has a high probability to be actually correct, the income basically of the route. And for now, our example with Germany, it would be the UK that we came up with. That would be the basically best route. So yeah, you can ask questions, and that would be our presentation.
Plus. You have any questions?
Sounds like a nice optimization problem. So let's say I'm a nasty CEO of this company now, and will tell you, well, what does the next 5 years have to do with climate change, especially if I extrapolate the last 30 years? Because the whole point of climate change is the future cannot be extrapolated from the past.
because I think this project will most focus from the company's point of view, or I would say like, for example, if you're as a company and you're the only importer in this country, and so with the time changes, of course, like for some products, their need also changes, and I just want to. So the idea is that with the time series, and you can kind of get the trend of the products, how it grows, and then at that point, like let's see like how much we need to provide, and then that's the idea why we did the present like prediction. Yeah.
Thanks.
Okay, yeah, just one. Thanks for the presentation. Just had one question on the climate hazards. Did you look at the different hazards that would affect soy in particular?
Yeah, so we took a look at different hazards like floods and droughts and stuff. And we also took a look at like agricultural hazards in general. And we found that normally there isn't like a big difference between like the general and the soy one. And I think for the soy one, it was floods and also I think droughts. Yeah.
Otherwise, we saw that, for example, in Brazil, the main problem was that the crops were too dry. And whereas in other countries where soy would also get planted, rather droughts and storms would be the problem, as soy is a quite sensitive plant, and that's why it actually both extremes are a problem for those crops. And we were considering of making like a still looking for every product that one could also influence how much every risk would be a problem, and that one could actually also quite easily put into our algorithm. But we thought now in this concept it's actually a bit over the top, and yeah, doesn't bring that much.
Okay, cool. Thanks a lot. Congrats. Yeah, thank you.
All right, good. We're on schedule. So next up we have team 8.
Thank you very much.
And you can start whenever you want. Sorry, Nero, can you set up?
It's a PowerPoint. They're all PowerPoints except for. Great. Are you all still awake?
Yeah.
All right. So, hi everyone. We're Team 8. We're calling us Risk Res. So I'm just gonna go over like our general goal first. Basically, we're taking data from Swiss Re, right? And we're using this data to basically assign risk or like sustainability ratings to different countries, right? And then we're giving this like model to your customers, and those customers can like basically use this model to optimize their supply chains, right? And overall, we especially emphasize on hotspots, which we like. Hotspots for us are like points on the planet where extreme weather events are like more likely to happen more frequently, and we're especially like focused on like long-term events because companies are maybe not very fast in like changing their supply chains, right? So that's our agenda for like this little presentation. We're first going to show you some demos, and then we're going to go like over how it works behind the scenes, and in the end we're going to kind of talk about the perspective, how you could improve it if you would use our model. So I'm going to give it over to Nicholas.
Hi, I'm going to be giving you a quick demo of the little tool we wrote. We looked at two commodities. Frozen fish is going to be the demo video, and then afterwards we have also looked at peanuts. Those are going to be a few screenshots. Oh yeah. Okay, So first of all, in our tool, you select the commodity. In this case, as I said, frozen fish. And all the countries that export this commodity, which we got from the UN Comtrade database, by the way, you can see the risk factor as computed by us with the Swiss Re data is shown. And then you select the country that wants to import it. And then the sustainability score will get combined with the risk score and will then be visible on the map, as you can see here. And you can assign scaling factors to these two right in our tool. And what's going to be interesting in the second little demo with peanuts is here you have a lot more riskier countries, in our opinion, and riskier as in climate impact. And this, if you then, for example, you say you are China and you want to import peanuts, you can then again assign different scaling factors depending on how you as a company, as a client, would think impacts you most or you want to optimize most. This is sort of purposely left to the companies to decide for themselves. We're just giving them the visualization tool.
Exactly. So how do these how does our rating function work? So basically there's two aspects to it. So one aspect is the climate risk, which is the risk of like extreme weather events happening at one place. And again, for this, we use the Swiss Re data. And the other aspect to it is basically this sustainability, right? So for this, we use a distance function, which is like a rough proxy, but like it's easily adjustable. And then we're combining them to create our rating function, but we try to keep it like customizable. So one specific method how you could basically rate a country, what we thought about too, is basically treating countries like stocks in a stock portfolio and assigning them a risk like you would to a share, right? And then basically calculating the total risk of your portfolio with this matrix, and basically the weights being the commodities you import. So this would be especially good for example, the peanuts, where every country is kind of high risk, you know, and you want to basically find the perfect solution for it. So lastly, we want to talk about like future developments and how you could like push it forward. In kinds of like risks, in terms of risk assessment, you could just use more like better models. The Swiss Re data is kind of patchy. Yeah, you could use more variables. In terms of customization for the customer, you could, for example, make it possible to include like more complex supply chains. We only looked at agricultural stuff where it doesn't have to really be how do you call it, like reproduced in different places, right? And the last very important thing that we want to say is that our method, when applied globally, also has a very big impact on the environment by just like if a country loses its rating, it has kind of a incentive to better itself in kinds of in terms of climate measures. Yeah. So thank you very much.
Great. Okay, questions? Do you have any questions?
So what would you say to a country that's sort of geographically very far away? How maybe would you advise that company to improve its kind of climate credentials if, say, they couldn't improve where they're located in terms of a lot of greenhouse gases will be emitted because they're so far away, but
Hi. So I think in general, like this metric we used is already not sufficient. So we would need to take into account geographical data and like the local aspect of the whole sustainability, So then they would not be so much impacted compared to other countries. And also, I guess it's a matter of like absolute in like relative terms, I guess. So yeah.
Perfect. Thanks.
Any more questions? You have half a minute.
Thanks a lot also for the presentation. Just wanted to ask if you saw any limitations on the mathematical model behind it, or did you experience any challenges there?
I mean, the computing power is always limited, for example, especially in this kind of scenario, right? So, yeah.
We wanted to use the Climata model as well, but it was just too computationally expensive in those 24 hours to incorporate that into our model. We wanted to try that at the start, but had to give up on it because it was just not feasible. So this is something that could be implemented as well.
Okay, yeah, thanks. I think that's a very important point. If you want to do the optimization and you need to run it a lot of times, right? For each optimization step, you need to have a very efficient model. And yeah, thanks. Yeah. Great work. Yeah, thanks.
All right, up next we have Team 15. You can take the microphone.
Hello. So yeah, hi, I already start. My name is Lennart, and we are Team 15, and this is Moritz, this is Anish, and this is Salome, which helped with the work. And we actually tried to implement an algorithm which can be easily scaled down and can be easily adjusted to a specific problem. And we, so basically, can adjust it to the scale which one is interested in. And this problem we thought is very suitable for optimal transport. So in optimal transport, you have first two distributions. So here depicted as purple dots and light blue dots, which are XA and XB. And you are now basically asking for a function which converts your first distribution XA to distribution XB. And this is an optimal transport theory, just interpreted as a flow. So this flow basically takes as an input argument the importers and the exporters. And you can also hard code a cost, which is easily adjustable depending on the problem you're looking at. And as a first example, we look at transport of coffee. So you here have basically importer countries and exporter countries. And you start with two distributions. The first distribution is XA, which is basically the distribution of exporters, so basically the countries which export coffee and which stay constant over time. And then also the countries of importers, which is XB. And what you basically take as a first example, as a cost function, is basically the distance between the countries. And you can then plug this into an optimal transport algorithm and see that when you basically only have the cost as a function, then it is very beneficial when each country takes engages in trade with every other country. So here only the total trade is displayed. So it's basically the sum of import and export for clarity reasons. And I will now hand over to.
Okay, and so because we have this general universal framework, we ask ourselves, how can we actually tackle those challenges of climate change and so on? And I think what the beauty of this framework is, then you can basically just say, okay, if we have climate change in the future, the product producers will maybe produce less of certain goods, or maybe due to political reasons, the cost to transport certain goods will change, and you can just describe this as some kind of function and plug this into your input, so the optimal transfer problem. And that's what we did. And for the case of rice, we took this climate change risk, and we basically said that based on this risk, the total goods produced will change or will be reduced. And what I show you here first is for each country the total exports and imports before we use the climate risk. And you see we have this very expensive trade routes again, or extensive, a lot of trades, every country with every other country. And after applying this risk factor and reducing the amount of rice produced, to show you this here, you see that we have much less routes left over, and also it becomes much more local. And yeah, so to give you an outlook, I think for future work it would be interesting to actually look at different cost functions and also how you treat the change of the input and output distribution based on climate factors and political factors and so on. And I think what's also interesting, it's a global solution. And so, for example, things like carbon dioxide, if you externalize this cost, you might have agents in your problem that do not actually follow the optimal solution. So it will be really important to find a good representation of this cost and also make sure that the participants actually face this cost. And so, yeah, thank you for your attention, and thanks to my teammates.
All right, so now questions?
Quick one. Thanks for the presentation. Just wanted to ask if you managed to estimate the amount of emissions that could be saved through that.
We did try that,
okay. Okay. Thanks a lot.
So I think the major problem there is also that we did not really have a sophisticated database available, which allows us actually to make a fair prediction. So for example, when we make an estimation for the carbon dioxide emission, we, for example, need actually to know how the goods and commodities are actually exported and imported. It's via land or via plane, and whether we can even optimize those trade routes. But since this common trade database actually encodes this in a very cryptic manner, I think this is like a very challenging task to come then up with an estimation which is fair.
So you mentioned on the coffee example that your countries of export stayed constant over time. Coffee is probably one of the commodities that we would anticipate in the future it will be hard to grow in a lot of the regions it currently is growing in. Would your model be able to account for that?
Yeah. I mean, that's why we introduced this T variable. Basically, in the end, it's just about how well you can describe the cost of trading, and how well you can describe the how much each country will produce. And if you have those models that describe this well, you will find the exact solution. I think that's the beauty of optimal transport.
Great, thanks.
All right, now we get to the last team, Team 19. Please come in. Yeah, and then we'll go for a pause. All right.
We're working on finding a solution toward a sustainable trade future. And I want to take first an example of the year 2018 in the USA. There were some severe droughts and causing some annual losses around 10 billions dollars losses. And this is a problem because USA is supplying a lot of wheat in the world. For example, Nigeria is importing some wheat from the USA. And this year, Nigeria was not able to supply himself enough wheat for his own consumption. So the question is that we ask ourselves is how is it able, how Nigeria would be able to tackle this problem in the future so he can choose his suppliers, but those are more reliable.
Let's take another example. Let's say we are Switzerland or a Swiss company and we want to buy rice. And since global warming is such a big thing these days, like, our company needs to ask two questions. First, how can you choose a supplier where we can make sure that its production is not too much affected by climate change, by increasing droughts or floods? And second question, how can we buy rice from a country where we don't need to like transport the rice all over the world and contribute to even more CO2? And so what our solution is we rank all the possible suppliers based on some climate risk score and based on the CO2 emissions when you buy the rice from this country. And then we aggregate it to find a score. And some more information about technical details. What is actually climate risk? Here we have data about each country. So one is, for example, how often do floods occur in India? How often do droughts occur in India, and so on? We have data about how vulnerable is this country for these hazards. And the third question is, how well is, for example, India able to cope with these challenges? For example, does it have the infrastructure to make sure that floods don't destroy the whole country, and that dams and walls? And so we use data from all these hazard vulnerability and coping capacity for each country. And the second data we have is, okay, how much CO2 emission is polluted when we transport the goods from India to Switzerland? And the way we calculate it is based on the distance, how far the way, or what, maybe ships are used for 80% of the transport way, and 50% is on trucks, 4% on trains, 1% on plane. And we also take into account that, for example, planes pollute the air more than trucks. So this gives us an estimate of the CO2 emissions. And this way we can have this assessment of how good is it to import rice from India based on the climate risk and the emission. And just to show you how it works, so let's say we are Switzerland and we want to buy rice and we want to know where to buy it from. And we say, okay, it's really important that we save CO2 emissions in transport. And so our program would show the list of the best supplier countries. So we see, for example, Italy is best because it's close, there are low CO2 emissions, and it's also not too much affected by climate change. And we also know how much the country can supply rice in total. And this brings us back to the habit.
Along with the model, we thought that we would provide countries some recommendations about how to reduce its food carbon footprint. So the first recommendation is that a country should try to consume more of the local and seasonal products rather than going for products that are imported from faraway distances. All the production, packaging, and consumption that happens should be in closed clusters, and there shouldn't be situations where fruit is sent from a country to another country just to chop it off and then sent to another country to pack it. And international policy frameworks can be formed to align goals of every country with each other.
1 minute.
And the government should promote public and private partnerships to mitigate the climate risks of the future. So now I would like to discuss why our solution is scalable. It has huge impact because it is dealing with the problem of climate change. And even if we reach the guidelines given by the Paris Agreement, we still would have global warming. So yeah, it's impactful. Our tool allows the country to get personalized suggestions based on their policy requirements. And the tool is country and product agnostic, so it can be scaled to any product possible and any country in the world out of the 192 if we have the data for it. We can also include other scores like the cost maybe, if that's more important to the country in the tool. And the risk that we chose in the tool is a combination of 15 different factors. So it also includes factors like political stability, the social stability of the society, and the CO2 emission scores that we calculated took into account the different
Time's up.
distances between the countries, like how different distances are based on the mode of transport. Their distance may be higher or lower. And we also take into account the transport mix ratios, that how much is transported using ship, rail, road. So yeah, that's it. And we hope that better actions today can lead to a safer and sustainable future for all of us. Thank you.
Questions?
So you mentioned for the case that you showed, India had a moderate risk and kind of a moderate emissions. What was the benchmark that you used to determine sort of the moderate rating there?
No, it's just that the final rating is between 0 and 10.
Okay.
So it was 5, so it was moderate.
Okay.
It's just classification.
Yeah, so it was a weighted average of the risk and the CO2 emissions. For the risks, like there's like data for all the countries, like it's rated from 0 to 10. It's approximately uniformly distributed, so it's more or less percentile information. And for the CO2 emission, we also defined the scale in such a way that it's approximate like a percentile and uniformly distributed.
Great, thank you.
Just a quick question on the technical implementation. Can you say 2 or 3 words about how you implemented your recommendation and optimization tool?
Yes, so we mostly first wrote a demo primarily. So for the risk, we have risk data. And for the CO2 emissions, we looked up the distances and estimated what's the transport mix.
But more on the, like, let's say programming side, like what technologies did you use? Like what programming languages maybe?
I mean, we use, the calculation was mostly just a weighted average. So we could use Excel to calculate the weighted average. But we also used Python, for example, to import the risk data to the Excel file.
Okay, thanks a lot. Yeah.
Yeah.
Okay. Thanks.
All right, so now let's just not extend this too much. Maybe we have like a 5-minute pause. We can also stay here. And next team is team 2 from SBB, so get ready. All right.
No problem. I could have I think we should find a better name. Like not called two flags to the city. Yeah. Also because Google doesn't find it. But I received an email for this one and I was like, oh, okay, cool. Can you student stuff? Like, can you want to go on? I think we're going to no. No, actually, I got an email, like, I got an email from the visit. Yes, so now I don't even have yeah, I got it.
Right, so please, people, come back to stage. I believe most people are on the J floor, so they don't hear us, but I already sent Nero to it, so. Otherwise, we can maybe start in. What do you guys prefer? Should we get started? I mean, the jury's here, so that's enough. You can use that mic. Yes. All right. Then that's it.
Hello. Good afternoon. This is Team 2. I'm going to skip the personal introduction because of the shortage of time. So we are doing the SPB challenge, and the overall concept of this challenge is to make people motivated to use public transport when they are going for leisure activities. So according to the information we were given from the side of SPB, you can see there is an entire inverse relationship between people using public transports during the weekdays and they're using public transports over the weekends. So we would have to mitigate with this problem. So we would have to answer 3 questions mainly, and the 4th one was like on depending on us. So the first question was to provide a click and go facility for people who are like newbies in using public transport, I suppose. So why? We have to start with the hiking. Well, we are in Switzerland, and Swiss people like to, introduce themselves as a hikers. And also the good part is if you see like the Swiss GDP, and if you compare the elements that it's out of charge.
Okay. I'm sorry. We'll give you a start time.
Based on ROI. So we don't have to get into prayer. So the second question we would have to
in order to tackle the problem, okay, it's a bit different now. In order to tackle the problem, we decided, first of all, to understand what's the accessibility of national parks. Therefore, we, starting from Zurich, Habe, we compared the accessibility by train and by car, and we found out that the accessibility by car is much easier. It takes less time, it's less complex, it's more direct, it's cheaper even for renting a car. And in particular, it's direct. It brings you directly to the final point. It has not the last mile issue. So now we wanted to understand how to solve this problem for SBB. First of all, we consider the fact that SBB and the Schweizer Park are already partners. And we also consider the fact that Schweizer Park is partner with mobility companies. So the idea would be that creating a synergetic collaboration between all the entities in play, the mobility companies would be able to tackle this last mile problem. In this way, the package that Ali was talking about before would be complete. And in this way would be also very simple for the customer, who would have a single point of contact with the company, and but we also thought that this might be not enough. So we also had the idea to introduce the possibility of a discount, of a 20% discount for the people that purchase a ticket, a package. In this way, a 20% discount on tickets for low occupancy routes. In this way would be, on one side for SBB, we'll have to deal with the discount, but on the other side, could increase the rates of occupancies in most routes.
Thank you so much. So the third question is very quickly. It was about to make the experience of, if I want to go to Geneva, you want to like retain me, like give me or motivate or make my trip more pleasing. So you put Geneva, you go to TwoPass. You click on go, you get the information which you already have on SBB app. Next page, you will get some good pictures with some history, with the map, actually the weather and the table reservation is already there, but we included the map, we included the main attraction points. Also, we provide our own packages because we are introducing a concept of ecosystem. So we need to retain our clients. We don't want them to go somewhere else or use any other service. So we're gonna bring them back to packages. So the last point, and as you ask us, what would be the inspiring for youngsters? For me personally, there is nothing motivating to use. I have to use it. It's a necessity. I use it. But if there is a fun box where I can have some games, where I can have music, I can have some alcohol, then I will be more motivated to use SBB. That's how we're going to create new values and new customers. And the last part is the ecosystem concept, the last slide, where we have one-click shop, where we are creating new values, we are retaining our customers, we are also utilizing our partnerships to provide the services, and we are improving customer relationships. Thank you so much.
Questions?
Thanks a lot for your ideas. On which one you would focus first in our use?
To be honest, if I would have access to your site and I know what are the more visitors, if they are the hikers, or if you want to, actually I would go with the city information. Like if people are going to Geneva, I want to give them more information. Instead, the current information is just select a table, you don't know where. And it's just a weather information with some multiple options of tracks. So I would go with first that one, the third question. That's the easy one.
And up next we have team 3.
So hello everybody, we are team 3 and I am Felix. I'm gonna present to you our project. I'm gonna do a small summary and lay out the goals. So at the beginning, we asked ourselves, what do we want to do? So we did a small brainstorming and we found some problems and we asked us one big question. Why do people not take the train and instead take the car? So we went out, did a small poll on the street, and as you see, had a very small sample size, but had a conclusion that most of the people don't take the train because there are poor accessibility to the train stations, and because there are like always delays, and yeah, it's not flexible. So we laid out a plan, and we have two big solutions to this. We wanted to create a new SBB ecosystem, which is quite similar to the proposal from the last team. And we wanted to make some improvements to the app. The improvements for the app, my team colleagues will cover them. So you're going to see them later. So it's quite similar as the last team, but instead of only using private companies which already exist, we want to propose a solution to like private persons to also give the car to the SBB while they're on a train ride or their bike. And so people who want to take the last mile can take car of other people. So you have a kind of car, bike, or any form of public transport which you can share for everybody. And then we also want to integrate cantons, cities and communes, which can then propose themselves means of transport, which they might know better the places and what kinds of means of transport are good and adapted to the place where they are. And this would make SBB like a central hub for everything, and then you don't have to need like 10 apps on your phone with Lime, Tier and everything. You have just SBB app, and SBB is connected to everything. So now Sam is going to talk about the app and some science stuff.
Hey, thank you for the word. So I come from a place, I come from a place where, you know, like we have more cows than inhabitants, and like it's very hard to go back home. But tonight, unfortunately, I have to go. I have to go see a friend in a small place. It's called Grange. And if I look at the SBB app, I type in Grange Village, and I realize, oh wait, it's gonna take a lot of time. Like I'm gonna take around 2 hours and 55 minutes to go back home, and it's way too much for me. And I'm like, if I'm very sleepy, I'm just like, no, I'm gonna stay in Zurich and don't go there. Never mind. But I'm from that place, and I know a little trick that maybe not all the people that will go there know, that you can just stop at Paris Gare, beautiful name, right? And like actually just do around 2 hours and 40 minutes trip. So we are saving around 1 hour and 18 minutes. And why is it so? So we realized, and like reverse engineering the app, how it works, like, and realized that maybe there is some fake, wrong assumptions on how the user behave. And we're saying that it should be more tailored made for the user. So put the user in the middle and really think about his point of interest, where you want to go. And instead of only looking into the closest station of the point of interest, we also look at all the other stations that are around it, and maybe look for soft mobility hub from this point of interest to this position. And for example, in this example, we see that from Grange to Palisieux, I can consider walking as a soft mobility or even biking. And for this, we can introduce some kind of advanced search with different kind of walking distance I want to walk, etc. And here is am I alone in this case? Is it the only place in Switzerland? No, it's not. And you're gonna see why. Here we have another example. I want to go to La Rosa. Oh my gosh, 6 hours and 15. It's on the weekend, Saturday. I'm like, no, I'm not gonna go there. It's way too far away for me. But actually, if I just didn't look at the SBB app, but would be a more smart user, but maybe some users are not, and they will just look at this and then take the car. What we don't want, because what we really want is to people to take to save time and take the train, and propose them this smarter solution to take the train and also take a 20 minutes pathway by the walking.
So I'm gonna speak about kind of how we found more evidence about the problem which Sam talked to us about. So what we actually did is that we basically selected two big cities in Zurich, in Switzerland, sorry, which are Zurich and Lausanne, and we selected a random sample.
1 minute.
A random sample of hiking places. And so we kind of used the API from SBB together with the Outdoor Active API to find how often, basically, does this issue occur for people who want to go to hiking trails for leisure. And actually, so we selected 250 random sample hiking trails. And well, the findings are that this issue exists. And actually in about 7% of the cases, more than 15 minutes could have been saved if one looks at other options instead of the one that the app proposes.
Time's up.
And yeah, so I will give the Nicolas about the solution.
Yeah, just really quick. We want to show the user that there's a quicker way if you walk. So we want to add a slider in the app where you can select your maximum walking time. So if you can't walk really good, you take like 10 minutes. But if you're like really sporty, you take 30 minutes. And then you see directly if it changes the total time of the journey. And then two other features of the app would be statistics, where some statistics would be saved. And this is just some sugar to keep the people on the app and on the train. And the other is discover, where you get recommended some places in Zurich, in Switzerland. And these are also coupled with sales. And the idea is to get people that usually use the train on weekdays to also use them on the weekend. So yeah, that's it. Thank you for listening.
Thank you very much. Do you think that our guests are open to walk if they travel by train and then they have to walk the last mile?
Well, I think that we specifically focused on hiking customers specifically for that reason, because they would be willing actually to just start a little bit earlier their hike. And but this is also why we want to have an adaptive system, right? Where we can have a slider, which, I mean, of course, some people, I'm thinking of disabled fear, for example, cannot afford to do that. Yeah, that's basically it.
Yeah, I think the main point here is really to realize that all the users that use SBB are not the same, and that maybe they have some advanced search that they really need to get the best experience out of SBB. And we think that for now there is real lack in this sense, and that's why we're providing this solution here.
I also wanted to add that this problem does not only affect people who hike and go to leisure activities, it also affects people who commute. So if you look, we did a small map, but we didn't have a lot of time to show it. And we see that also in more urban regions, like the darker color means you lose more time, and the brighter the color is, you lose less time. And those are only the affected points here. And also in more rural regions, you lose a lot of time by not walking. So you could take like 10-minute walk and sometimes have much less time in your travel. So it's like a feature or a bug in the SBB app, I guess.
Great, thank you. Now we have applause, exactly. And now we have team 5.
Okay.
Hi, everybody. So we are from Team 5. And when we tackled the SBB challenge, we thought about what are we looking for if we doing leisure trips? And what would motivate us to take SBB instead of something else? So what we're looking for, maybe an amazing outdoor activity like standing on this rock and having this great view. Or also other important points for us are that we want to get there stress-free and with easy planning. We don't want to waste hours in preparation of how to actually get there, how to combine multiple trains, what to do with our luggage. So what we are actually looking for is convenience. We want SBB to be convenient, more convenient than taking our car. So what can we do to make our activities, our leisure activities, more convenient? It's streamlining decision-making, and for that, we propose a convenience rank. So if we go hiking, for example, we care that, or whatever activity we're doing, we care that our destination is close to the next train station, to the next place we can leave the public transport. We also care about how long the train ride takes. So it's more convenient if the train ride is faster and if we don't have to change many times. And of course, also we have our preferences. Like we actually know what kind of activity we want to do. If we want to do a nice ski tour like here, an easy hike, or go to a hotel or whatever. So what we're trying to do is guide people to make smart decisions, to get inspired in a smart way. And our approach is that we rate outdoor activities in this case by a convenience factor on an easy-to-use platform, which basically offers also an option for random inspiration with a lot of convenience and, of course, more flexibility because with SBB for outdoor activities like hike heels, we can start and end at different destinations, both nicely connected with SBB. And we want to have it easy to use on a website or on an app. So what we did is our convenience rating. We went through the outdoor activity database and we collected the data from the weather API and of course from the SBB API. And we checked for all the entrances on the outdoor activity portal, how convenient it is to get there. And our convenience factor that we plotted here is, for example, the time it takes to get there versus the last mile. So the closer you are down here, the more convenient it is. The farther up here you are, the more of a hassle it is. And you can clearly see that there is a good region down here where it's reasonably convenient. And this would be nice trips to do, while the ones further up here are maybe less convenient. And in return, this would also be assigned to SBB. Hey, maybe we can add a shuttle bus to this thing and make this trip that has a really good rating maybe on the outdoor activity app more convenient. And of course, this is the last point. You also have expectations. So if you really want to do the trip up here, yeah, these are your expectations. You're not going to have a convenient trip with SBB in the current state. But we really want to tackle this the other way. Try to inspire the people that don't have a fixed expectation yet by adding, by giving them inspiration of what they could do really easily. And for that, till now you saw the backend, and now we're going to show you the front end we programmed over this weekend. And it's as easy, as simple similar to the SBB website or app. You add your place you are currently. You maybe even want to add a certain destination a region where you're interested in, your date and time, and you get inspired by beautiful pictures directly from the outdoor activity API that suggests you cool things to do. With the next click, you already get the full program of where you can, when you should take your train, where you exit, and what your hike is going to look like. All the data from the outdoor activity website with how difficult the hike actually is, what to take care of. The only thing that's missing at the moment is that you can't buy the ticket directly on this demo website we have here, hosted on our local host. So, what could be done now with this? So currently, we only looked at outdoor activities because they provided a nice API. We had time to look through it this weekend. But of course, there is much more points of interest that you could go to. You could look at outdoor activity at the Swiss parks, at hotels or restaurants via Gastronomy Swiss, or recently the Swiss Alpine Club published for all its members a huge database with tours and trips published nicely on the Swiss map and with tons of filters of what you want to choose, but there's missing the convenience rating that you could use to sort for it. And SBB, as the previous people already mentioned, has already this Freizeitangebot website where you have a few hand-curated ideas, but we would increase the number of ideas on there drastically. And of course, since we are from a younger generation that uses app, it would be very nice to have this in an app setting. So, in conclusion, what we're trying to do is guiding users to smart decision making, give them innovation, get them to have a convenient trip, and the whole thing is fully integratable in any kind of website or app. Thanks for your attention.
Questions?
Thank you very much. Have you maybe one or two concrete examples for convenience trip? What you found this weekend?
Yes, actually the example on there, like these were actual examples from, I think it was from Bern to Ilanz, right? This was around Ilanz, so you get, I don't know, Frohnalp, Glarner Alpen, Saalhöhe. These are all trips that are, this is a screenshot of a live demo. Like this works on our GitHub, which was on the last page.
Did you want to ask? Okay, then thank you. Applause, yes, applause. Next we have Team 9. Is Team 9 here? All right. And can please, what is the team we have next? 10. Yeah, pretty obvious. Team 10 can just prepare, come closer. Thank you.
So, hello. We have already been living here in Switzerland for 2 months, and this weekend we asked ourselves, what is the favorite hobby of Swiss people? So, some of you might say raclette, cheese is really good, chocolate, but I think that we can all agree that the most beautiful thing that we can do here in Switzerland is hiking. But with hiking we also have some problems. So?
One of the main problems SBB is facing is that a lot of people still take the car to go hiking. As you can see in our beautiful pie chart, about 75% of the kilometers traveled in Switzerland is done by cars and motorcycles, etc. And only like 1/5 of it is done by train during the weekends. So the main reason for this is because it's the simplicity of just taking a car. You can just hop in your car and you don't have to take into account when you want to get home and stuff. So the main thing we want to solve is we want to make the taking the train more simplistic, because that way taking the train will be more enjoyable and more easygoing.
We came up here with our solution that you can see on the right. Our solution is, as we said, quite simple as taking the car. It should be an SBB integrated feature with a simple button called Take Me on a Hike. We can choose there simply the date of the hike and the time. And with some preferences, this app, it takes a bit of time, and I know that the GUI doesn't look that good, but it works, and we get the best hikes that we can do that day. It takes a bit of time, as I said, and we get a bit of information about the difficulty of the route, and also the time that you need to get there.
And back to that device. We tried to use as much data as we could to pick the best hikes to use. So we looked at the weather, we looked at the time taken to travel, and we looked at the feasibility of actually making the trip. So if you left at a set time and you got there, would you be able to come back after doing the hike? Because obviously we don't want to show you things you can't do. Yeah.
Another feature we were thinking of adding is called green tokens. This is some form of currency that you can get while taking the train. And the idea is to gamify travel. Like almost everyone likes games, and it's pretty satisfying to see some sort of currency rank up. So the idea is that you collect coins for the amount of kilometers you've traveled by train, and the coins are calculated by the amount of carbon you saved by taking the train instead of the car. Afterwards, you can also spend these coins. Maybe you can get a discount on taking another train to a new hike, or you can even, we thought maybe you could even donate it to a nature park or something. And the thing about it is maybe once you're close to getting a discount, maybe you'll definitely be more likely to take the train. Like, oh, should I take the car today? No, I'm close to the limit. So that's the idea behind it.
I'm just going to explain to you a little bit about how we made the algorithm. We started off with doing a first scan of Switzerland and looking at all the hikes and checking the weather, and then we ranked them in terms of like the wind, the sun, and the temperature and stuff like that. And then we were able to like get a short list of ones we'd like to look more into. And then we got the journey details for this, and like how long it would take to get there and if it was feasible. And then we ranked them based on these results we've got for this. Yeah, and we could just easily display it. And we also calculated the green tokens and how much it's per kilometer. So we'd work out how much you'd be making. And then finally, we displayed it in this easy to use user interface. Oh, okay, what's next? Obviously, we didn't have a lot of time to do this, and we would have wanted to do more. It'd be nice to integrate this with the SBB app. Add some more personalization, so like how many people, and if you don't mind going far or don't mind the snow and things like this. And we also had more information to put on the user interface, like which exact trips to take, but we just didn't have the time to do that. Yeah.
Just at the end, here a quick overview of our team. We are all Erasmus students enjoying here our Erasmus semester in Switzerland, and we love hiking. That's why that was a perfect topic for us. If you have any questions, like, feel free to ask them.
Yeah, so thank you very much. I hope that you can hike and travel by train in Switzerland when you're here. So do you think that also without the tokens, our guests will use your app?
I mean, we'd hope so. I know I definitely would. Often there's lots of us that want to go hiking on the weekend, and it's just a hassle to find somewhere to go.
We all live together in a residence, and we all try to organize hikes on the weekend. But it's always like quite hard because we have to take a look at the weather. We have to take a look at which hikes are nice, and if we don't know a lot about Switzerland, it's quite hard to get somewhere. And that's why such a feature would be ideal for us.
As a fellow foreigner, do you think that maybe part of this integration to maybe appeal to our crowd would also include some sort of audio descriptions about where you're going, or even sort of a podcast while you're on the train to tell you what you're looking at?
Yeah, that'd be great. Yeah.
That would be great, but I think this is also a bit maybe more harder to do because you have to record the full podcast. But yeah, it would be like a nice solution too. we haven't thought about it, if
We
I'm
have to
honest.
learn about like the history and the culture of
Yeah.
what you're seeing as well.
Yeah.
All right. Next we have team 10. Yes, they're ready.
The right promotion to the right person at the right time. We think this is how SBB can increase mobility and the use of the people in leisure trains, especially during weekends. This will work in two ways. First of all, we can convert current users of cars and incentivize them to switch from the car to the train itself. Second of all, we can incentivize the people who are on the fence and get new riders who are considering it to switch and take the train instead. We'll take an analogy from chemistry here. We're trying to essentially lower the activation energy of the users to encourage them to take this trip. So our vision is based upon a principle of intelligent offerings. We want to take the right promotion to the right person at the right time. We're going to do this in essentially two main ways. We will generate smart deals based on the environmental factors, primarily based on partnerships which already exist and are very well established. We have train occupancy and we have weather data, and we can use this with the conditions and locations to give good suggestions for the person. Second of all, we can leverage our existing user data to give the targeted promotions specifically to who needs it at the right time and place. We can nudge people into empty trains which are otherwise unused.
Incentives. I'd like to talk about incentives. We want to create new incentives that are going to push people over the hump to get on those trains as opposed to taking their cars. First thing we need to do is create those incentives. But we have the incentives. We need them to go to the people who are going to best utilize them, right? To do this, we use a user compatibility score. What's a user compatibility score? It's simply something that assesses the compatibility of, sorry, I've said compatibility a lot, something that assesses the compatibility of a person to a specific route. In parallel, we'll leverage artificial intelligence to make sure that the right leisure category is assigned to the right person. So just speaking about incentives for a minute, SBB themselves can offer a wide variety of incentives. Price discounts perhaps the most obvious, right? If you have a targeted system, you can lower the price. If there's, let's say, low occupancy for a specific route, that train is going anyway. Let's put those people in those trains. Let's target that for those people. However, I think the real potential of incentives and promotions lies in the utilization of the external partners, the partnerships that SBB has cultivated over time. For instance, a beer tasting or a wine tasting. It would be far more responsible, of course, to take the train than to take the car if you're, say, a family of four or something and the parents want to enjoy their time as well, than to drive and then one of them have to give up that opportunity. So I'll pass you on to Stan.
So, as John said, we want to leverage the power of artificial intelligence, but it's too complex for an artificial intelligence model to directly predict a deal, a promotion for a user. So we're going to break down the problem. First, we want to get this list of promotions, this list of deals. How do we get it? We have two ways to get it. A human way and an automatic way. The human way is basically this curated list that is based on ongoing events and is maintained by an expert in tourism, local expert in tourism, or at least someone knowledgeable in tourism that is going to maintain that list. And we have automatic processes based on the weather, for example, in different places, and occupancy of the train that are also going to feed some deals into that data box, basically this data bank of promotions. Now we think machine learning models are still not powerful enough to directly predict which one of these, even if you don't now we get them, go to who at what time. So we're going to use the machine learning model to predict which type of leisure. We will see that right after.
Once we have the type of leisure, we want to assess the compatibility between each promotion within that type and the customer at the current time. So we designed this user compatibility scoring, which is based basically on how well the deal is matching the customer. Is it too close to them? The thing they're going to attend, is it too close to them? They don't need the train. Is it too far from them and it's not doable? Is it a deal on a pet and a bike and they own a pet or a bike? This kind of thing is going to be for the compatibility. And that's how we're going to design the compatibility scoring. Then machine learning. We want to predict a leisure type for a user at a certain time. However, we need labeled data for that. To train a machine learning model, we need data already about those leisure types for past history. We don't have it. SBB doesn't have it because it's something we came up with. So we need to design a way to collect that data. We do this with an initial model that is based on social demographic data and that is going to do an educated guess of which leisure type fits best which user at a certain time. Obviously, it's based on time. We won't offer a summer thing in the middle of the winter. And once we get this, we use the compatibility scoring to get the best deal. For example, a promo on a mountain bike fare in a train. Once we do this, we suggest the deals to the customers, and whether they accept it or not, we record this and we build a data set based on that. Then this data set is now labeled data that we can use to repeat the exact same process, but with a machine learning model, a deep learning model, that is now going to have to pick up some things the human mind couldn't pick up and do much more precise prediction. Same kind of thing, prediction of the leisure type, and then based on compatibility, optimal promotion within that leisure type. Concretely speaking, we could reach you based on the data we have through the app, through a push notification. Note, we could also send you an email or even a paper mail. So, ding, you get this notification, you click on Discover. We want to reach the right person with the right promotion at the right time. You click on it, you go to the target promotion, and off you go to Basel to visit a museum, and you saved 15 kilograms of CO2. Thank you very much.
Questions?
Yeah.
It's quite interesting. Is it easy to produce to practice your model?
So we did a proof of concept. We submitted a proof of concept. It's nothing is nothing is impossible. I think the thing is that you have this phase of data collection that you need to do that takes some time, especially if you want data that is going to be representative of the full season cycle. So it's going to take 1 year, like for the whole season cycle. And this is going to do less suboptimal promotions because it's not based on a machine learning trained model. It's going to be based on, as I said, an educated guess based on social demographics data. So you have this cost. That's the main difficulty, I would say. Letting this model run to gather the data. Once you have the data, it's very powerful. Now we maintain ourselves to a very strict ethical process of not buying data from third parties on the customers. If you do this, you obviously kickstart the whole thing way faster and you can directly train a machine learning model. But we try to do it only within SBB with the data that SBB has and only collecting directly, completely self-contained.
Any other question? No? Okay, applause. All right, thank you. And now we have team 11.
La la. Can you hear me in the back? Amazing. Okay, great. I think we can start. Hello, everyone. I'm here to present you our hackathon project, SBB Getaway, bringing travel to the users. So what we designed is an app that takes the initiative. So we designed a recommender system that requires nothing from the user. What you do is you just get an opportunity handed to you that's personalized and should interest you. Let's see how this works. Saturday morning, you didn't really think ahead about your weekend, didn't make any plans, but you're thinking, would be nice to get out of the chair and move sometimes. And you don't even have to think about it. You just look at your phone, and there it is waiting for you, your travel plan that's personalized. We click the notification, and we're taken to a trip view, which basically has everything that is needed to decide, do you want to go on a trip or not? Obviously a short description, but what we also get is the price, commute times, and also what we think is very important here is a discount on this specific offer that's tailored to you that you can also share with your friends. So you can go on a nice hike that you're gonna like cheaply with your friends. Great. And if you're not really content with that proposition, you can browse an Instagram-like feed of other offers that are all tailored to you too. So we can go see the penguins at the Basel Zoo or whatever else you like. But maybe sometimes you don't want to wait for the notification. So what you can also do is you just go into the SBB app, because all of this functionality we would plan to be implemented in the SBB app, and you just either click the widget or the icon, and you're taken again to the feed that you can scroll. Everyone loves scrolling, right? So we know how it feels like to use it, but how would this actually work? And I'm here to convince you that it would work. So the flow of generating the recommendation would be AI-based. So first you take the user features, trip history of the user, and other stuff like weather, time of year. You put it in an AI model that generates personalized list of destinations. Those are then filtered by whatever the user needs, meaning how far can he travel, does he need accommodations like wheelchair accessibility. And this way we produce a list of reachable destinations profiled for the user. And let's take a bit of a deep dive here. I'm not gonna go through how this works, but I just want to make a couple of important points here. So this is basically the structure of the recommendation engine, and as the input, you either have the user features or also the user trip history. This basically means that even if the user doesn't have any history yet, we can make viable predictions for him. That's often a problem in recommender systems. But then the more trips he makes, the better is the recommendation. Also, this is a model designed by Facebook called the LRM, and this is basically one of the state-of-the-arts that you can do there. So this is tested well. And just a look from the sustainability perspective. So day trips just in Switzerland by car, just the day trips, right? So no longer trips or commute or anything. That's 2.4 billion kilometers yearly, quite a lot. And switching to train instead cuts 95% of the CO2 emissions, right? This is, just to picture it, an equivalent of 2 million trees, right? So this is a win-win situation. Users get their trip planned, SBB gets more money, but also it's better for the environment. And also we want to say a bit about how would this actually be introduced in the market. So the first step would be to offer discounts, of course, because this is a new service, we would need to make the users want to use it, right? So with those discounts, we could reach the early adopters. And now a bit of a sidetrack. You know there's this service called Railway. It's basically a search engine for trips.
1 minute.
So you can find your stuff there, put in how far you want to go, etc. But it's not recommended at all, and there's so much clicking to get there. So we would want to reach people who bought tickets for Railway, reach them with our offers, use the data of the recorded tickets to train the initial system. Based on this, for those people, they would be able to gather data, improve the AI model this way, and then Once the AI model is really polished, we expand to the wider user base. So just to sum up, what we want to achieve with this project is when you want to watch a movie, you open Netflix. You don't even have to know what you want to watch, right? You want to go on a weekend trip, you just open the SBB app. Thank you.
Thank you. Questions?
Yeah, thank you also for your concept. Do you think that our customers are open to give their data? And yeah, I mean, it's like an open.
So for, I would say from the data privacy perspective, what we would actually need to store is what tickets were bought through Railway, and this is stored anyway. So I would say this is not really a violation from any side, and of course this is an opt-in or opt-out service, right? I wouldn't ever force it on anyone, of course. Also, by looking at the numbers of app downloads, which is above 5 million on Google Store, and I don't know on the iOS Store, Swiss people are willing to use technology to move around. So here we are.
So I would have a question to the sustainability argument. So what your app will do is make people go more on trips and not replace car trips. So what you will generate is actually more pollution, not less, because train is not pollution free. So what would you say to that?
I think most of the solutions here are actually...
I agree. You just got the question.
This way, right? So I think it's not necessarily only converting people from not going anywhere to going for trips, right? I think we can also convert people who go by car, because having a full trip plan handed to you is way more convenient than actually having to think about where am I gonna go, are there parking spots, parking in Zurich is awful and all that, right? So I think it's also the convenience here is a big argument for people who use cars.
All right, thank you. Next, we have team 12. Careful with the camera. Yes.
So, hello everyone. Can you hear me? I guess not. Can you hear me now? Yeah. Okay. So, hello everyone. My name is Peter. I'm from the group 12, and I will be presenting you today our challenge to the SBB problem under the tagline, over the weekend, take a trip to your favorite scene and get the best discounts by collecting our leaves green. So to start off, we asked ourselves why people choose to go by car. And as a foreign student, I can tell you that one of the main reasons why I would choose to go by car is the cost. It is evident from this graph that the more people you choose to go on a trip with, the less sense it makes to go with the train. It makes more sense to rent a car. So with this in mind, we asked ourselves how we can improve of this situation. People will sacrifice sometimes the cheapest option if the other option is more convenient, if the other option has better qualities that you appreciate. And so we thought, as a problem, to find a hiking trail right now, there isn't a centralized place where you would do that. you need to search for through many different websites, and you need to search. You need to know what the weather is like. You need to put in a lot of effort, and this prevents people from making decisions, from having a seamless experience. So our idea was to make an app, and this is an improvement on the SBB app. You choose different. You can of course choose different parameters that suit you. You can also filter things. So maybe you have a dog, or maybe you have a child, or maybe you don't want to cook. You want to see if the hiking trail has a restaurant nearby, and similar things like that. With this in mind, once you select all of your sort of requirements, you get a listing of all the things that you can visit that are near your point of interest. And once you choose, you can see many different information about this. Once you choose a certain destination, you get additional information. And now, so the additional information can be like, when will you depart, when will you arrive, what the price is going to be, and so on. And also, you collect something that we call green leaves from the introduction, if you remember. The point is, for every, so they're listed on the here on the left. The point is that the more CO2 you save by going by train, you get more green leaves, and they go into your wallet. And after some time, once you collect enough of them, you get a discounted ticket for a weekend, discounted weekend SBB ticket. And with this, we have implemented a proof of concept application that you can all open right now if you scan this QR code. It is of course, given the time, a semi-functional app. But if you type in the search criterion, you type in, for example, Zug, you will see the nearest points of interest from there. And with this, I'd be very glad to answer any questions you might have.
Applause.
Did it open? Did it not? It cannot not open.
I think we might have-
One. Yeah, I'm terribly sorry. You need to be logged onto the ETH Wi-Fi. Otherwise, it doesn't work. It's on the local network. Terribly sorry about that. Didn't mention that.
So I noticed on your a couple slides back, you showed sort of the amount of time I think you would spend on each hike. How did you kind of come up with numbers
so
for
the
that?
idea of this is you have a starting time, then you have a length of time that it takes you to get to the starting location of your trip or your trail, and then it tells you how long it takes. It also tells you what the weather is like, tells you if it's sunny or if it's raining or if it's cloudy, and it tells you how long it takes for you to get home. It tells you when you start, when you get home, and it also tells you how much CO2 you have saved by doing so.
And also the time that is in between is from their website, and how they said that the route is 3.5 hours for this hike route.
Yeah.
So we took this into the account if you want to do it within 1 day. So that would be the shortest possible time that it takes to do it.
Great, thanks.
Okay, and the app, it's a bit difficult to see if I'm holding it with my phone. But the way it works is that it is a functional app. It is not a mock. So when you type in the location, you get a list of all of the points of interest that are near the point of interest you have chosen, and that satisfy the certain criterion. And you also get the full round trip. So you say, I want to go from here, I want to go on to this trail, and I want to end up here. Yeah. I want to end up here, and for this you get the amounts of leaves you collect, the amounts of you know what the weather is like. You don't have to visit external websites to find that out. You know if it's accessible by bike. Once you click on it, you get a timetable, and with this you can also adjust the time that is put in the application is the optimal time that we think most suits you. But if you open it up, you can actually see, like in the SBB app right now, you can see multiple options. When will you start your journey and when will you end your journey? Yeah. Does anyone have any more questions? And did anyone manage to get it running? Terribly. You did. Who else did? So top rows works. Well, maybe you're connected to the bottom Wi-Fi. Maybe for some reason it doesn't route well.
So, Christoph, do you have any?
Thank
question?
you also very much. Do you think that with your app, much more people are using trains, or is it needed to bring cheaper tickets?
Our idea is that you get people to use the train more. Yes. The primary idea was not even to have tickets price reduced. The primary idea is to provide convenience. When you have, you cannot, the thing you can do, the people, when the purchase of a ticket is one click away. You sign up, you say, I want to go here, and you are 2 clicks away, 10 seconds away from purchasing a ticket, and you're on your trip 2 days after, or maybe tomorrow even. Maybe even today. It's that kind of convenience, I think, would incentivize people to buy train tickets. The ease of use.
All right. Thank you. Next, we have Team 14. Please come down. Applause. Yes. Sorry.
Happy applause sign.
It's quite late already. We have just one team after this one, and then we can all go up and eat pizza. It's actually getting cold already, but I hope it'll still be good.
That's fine, yes. Yes, mic works perfectly. All right. So we've heard a lot about how we deal with our leisure plans, especially on the weekends, where we have a lot of free time and would usually go on a trip. But it turns out that a lot of the times it's just too much of a hassle to actually go on the websites and look on this app, look on that app, just have all of the different things that we have to take into consideration before actually going on the trip. And that's not what leisure should be about, right? It's about us going on an adventure, on things that amaze us. And it's certainly not like dry planning, that is. It's just cumbersome. It's not what we want to do. So our team solved this task by creating an app, like we've seen sometimes today. And the approaches are also similar. So we use data. We use data that is connected to you as a user. We start at the client, who will provide us with the personal information, for example, through his SwissPass login, and also external data like weather information and occupancy of trains, which will be or which we retrieve from the APIs that the SPB gave us. The next step is to actually recommend you the best fits for your needs, and also have only a few fits for these. So we don't want to give you the painful choice of like having to choose from a plethora of things, because that's exactly what we want to mitigate, right? That's where we're coming from. So what we use is, or what we would use if we had the user data provided by SBB, we would use a dense neural network, just as other groups mentioned, and would generate the recommendations from there. The next and very crucial part for us is to make this planning experience a whole experience. We want the impressions you get from your travels to last.
We want these not to be like one-time travels. You went to Rigi one time and that's it. But we want to have you plan and record your own travels for your own sake. And along with that comes a lot of socializing, which we will come to later. But first, we made a functional version of our app, which we will demonstrate now. So this is our web app, which is supposed to be launched on mobile devices later on. And as you can see, we are first welcomed by the app, and also can see the weather for us right now. It's taken from the weather API. And right off the bat, we get recommendation. We don't even have to do anything. We just get the recommendation right off because the app already has all the data it needs to give us these. So for example, here we have the Swiss National Museum Zurich. Also displayed is the total duration of any trip and the location where it's at. There's also a variety of different activities that are of different types. So for example, if the recommendation system is not quite sure, you can take paragliding in Interlaken if you yourself feel adventurous today, if you feel that you can take some more physical prowess or some other hikes, as opposed to the National Museum we saw at the beginning. And let's say we want to get to the hike at the Aletsch Glacier, then we would see this information we talked about before, and we would see reviews from other users. And this is integral for us. We want SBB to be more community-driven. We want it to be something that is shaped by the community itself and something that we want to use as a community. So if we actually go on to buy the ticket, we can see our tickets, of course, and also the activity information that we'll need for the trip. For the Aletsch Glacier, that's the walking or the hiking trail, and also the coordinates, starting and end points for the hikes. Also the return trip, the trip inbound, of course. Then we can go on our personal page, which is very important to us, because it gives you all of the information for your profile, Swiss Pass, and everything connected to it. And you get an interactive map where all of your travels are recorded. So that is where you can track your progress and get maybe motivated to explore different areas you haven't been to yet. And at the end, we have a histogram recording the kilograms of CO2 you saved by taking the SBB. SBB saves 30 times more CO2 in comparison to travels by cars. That's immense. And it really is different if you see these numbers right on paper in front of you in your profile. And what we strive for is to make this a competition with you, yourself, and others. You can compete against yourself, saying, okay, I hadn't had a lot of leisure rides these days, and so I could push for more, or you could compete with others to get these. The main point is that you will see your progress immediately, and you will be motivated to go on more travels.
Thumbs up.
Thank you. Thank you.
Okay. Perfect timing. All right, thank you. Questions?
Thank you. How can you be sure that a person after using your app is taking the train and not the car?
So,
I mean, yes, you've got all propositions, and how do you attract the person then to really to use the train and not to be inspired and then on the other hand use the car?
One motivation is, of course, the community factor we introduced. So we imagine some kind of binding oneself. It's a challenge one takes upon oneself, because we always say, okay, I need to go on more leisure activities, and then we're on the weekend and we say, oh no, I don't have any energy. And this is something that drives you. It's something that you can't control as much as your car, but you maybe don't want to. You maybe want to take on this challenge yourself and feel better about it afterwards.
So actually, we don't want to force anyone. So it's all options. They can even use our app and go with their car. but then we also calculate CO2 for them and the cost for them, like parking lots and also the petrol, and then all these basically repair costs that they should take, and also maybe the risk for accidents. And they are their own. But on the train, it's more enjoyable. We are maybe planning to have more games for more dating also. If you're planning for meet up some people that going to the same destination, and it's more fun. And you don't need to also focus on driving and be stressed out. We can also have some partners. For instance, on the train, we can offer them to read some free books or watch some movies and be guest of us. That's why we just, there's availability. So it's their choice to take it. And we don't want to push anyone to do it.
Yeah, so these are abstract solutions, but much more subtly. We don't provide you with an activity. We don't provide you with a route. We provide you with the whole trip, right? There's no separation. We provide the exact time you go into the train and the exact time you go back out of that train, and you have made the whole round trip. And that's how we plan to get the people to take actually the train, because it's so easy. It took literally 2 clicks to get to that page. I mean, modulo the paying, right?
So I will just ask you the same question I asked before, but when you say saving CO2, this is basically a lie again, because if you want to save CO2, you should have reduced both train and cars, just cars a lot more. So maybe a differential would make more sense.
Yeah, that's basically what the API computes. It computes the differential to the car.
Okay, so it's not saved in absolute.
Actually, it's very complex. So because human beings want to travel and get adventure, and anyhow we are polluting because we are living, and we are just want to feel better than yesterday.
All right, thank you.
Applause. Okay, now we get to the end of it. Last but not least, team 19. Quoi? 17. Sorry. Yes. I'm very tired. Applause. No, you already have. All right.
Meet Mike. Mike is a simple guy, and he has a simple plan. Mike wants to go on a hike on the Rigi. But Mike doesn't look so happy, does he? He just spent 45 minutes looking at the trip he was going to do for the Rigi. So he looked at the weather forecast, he looked at the route he was going to do, he looked at the duration, he looked at blogs on how good it was, and so now he has like at least 10 tabs open, and he still hasn't even booked his trip. So we offer Mike a great solution. We want to add a service to the existing SBB app called Book a Journey with SBB Leisures. So this is what the platform looks like. So Mike is interested in a hike, so he would choose a one-day trip. So, because Mike knows where he wants to go, he selects Rigi Mountain and the date and the type of activity. So for him, it's a hike, but it could have been biking, skiing, other nature sports, but also wellness and spa. So what Mike gets on is like one page that tells him the description, so the length, the duration, and on, the map of his hike, altitude, but also the weather, and even ranking and comments about customers who did this hike and who enjoyed it or not really, and why, so he can get insight. And from this page, Mike can directly book his ticket, and this ticket is going to be optimized for Mike's hike for like the time. So it's going to propose the best schedule and the least connections for him to do this hike. So once he booked his tickets, he gets this whole interface. So The SBB Lasers is going to follow Mike on his whole trip. This is his train trip, so you can see he is followed on his whole train, and changes are made really easy. And he's also followed on his hike, so that's great. He doesn't have to have 2 apps, but only 1, because now we all have this app tracking us on our treks. And also, what we found important to include is that often you book your train ticket and then you need your cable car ticket, and this would combine both, which would be a big save a lot of time. With SBB Leisure, we don't only allow a trip, we allow a whole experience. And what does that mean? We want to start the experience once you put your first foot in the train. So, let's say I'm in the train and I see a beautiful lake and I'm like, what's this lake? Well, my app will tell me if it's 10:48 or 2 o'clock, the lake is pretty much one of the 13 lakes. You'll have fun facts about everything you have around in your trip. So, yeah, you have a whole experience and not only a trip that's transport. And also, we thought we would put little warnings of live warnings, like be careful, it's gonna rain, so maybe you should postpone your trip to next week. So we did a little Instagram live survey during these 24 hours, and we asked young people, why do you take the train? What's your the strongest argument for you to take the train and not the car? And 40% think sustainability as the main argument. We also had comfort or speed. And so we thought, okay, how can we add this to our app? And this is where we thought about the little my current savings, of CO2 emitted train versus car, meaning that I took the train, not the car, so I saved this much. And we thought we could also include rewards. So if I arrived to this much CO2 saved compared to if I had taken the car, I would get a discount on my next trip. So this is a second case. So this young couple just got married, and they want to go on a romantic weekend, but they don't know where to go. Well, thankfully, our app has a solution, or our service. So instead of selecting where to, you can select personalized destination ideas. And here you can select travel time, target couple, so target group, here we have a couple, but it could be a family or a group of 10 people, and accommodation type, price range.
1 minute.
And so this is what they're going to fall on. So it could be linked to Hôtellerie Suisse, which is already a partner of SBB. And so they can select an experience. And if they do so, they don't only get the price of the hotel, but it also includes the ticket. And extra features like they can select the luggage service, which brings your luggage from your home to the hotel and then back. And it actually already exists and is free if you select this all on SBB, but not many people know about it. So yeah, you also get the timeline and the map to live the full SBB experience. And yeah. So yeah, the couple is really happy. So to conclude, how to get people excited to use public transport for leisure? We think our app is the solution. It's simple because it combines everything in one package. It's personalized because it selects target groups and gives them a personalized solution, and connected because it connects SBB with their customers and some of their partners. Thank you.
Applause. All right, thank you very much. We might have a couple, questions?
Yeah, thank you also. What do you think are the steps to integrate an app like yours in the SBB mobile?
tips, you mean?
The next steps to integrate, yeah,
Well,
your solution
yes.
into.
So what we realize is that many of these features already exist on the SBB webpage, but they're really dispersed and it's hard to like find them. So it could be just to like all combine them in one place. And so we thought it could be like, if you see at the beginning, like, just add a little book a journey with, that means like my weekend journey. And then, yeah.
Any more questions? Nope. All right, thank you. Applause. And now, yes. And now you can all go upstairs to the GA floor to eat. The jury will have around 1 hour to deliberate, and we can meet back here at 4:30. Is that all right for the jury? Or we'll let you know, but around 1 hour you can be back here. All right. Applause. No, I'm kidding. We can all go to the Hello, we invite everyone to join us in the stage room. Well, on stage, please. The award ceremony is about to start. Please try to wear your masks, especially in front of the camera, please. I don't know. All right. So I'll just assume that everybody's here. We can get started. All right. All right. So first of all, thank you for being here. I know it's been quite a hectic weekend. We probably none of us got any of sleep in the end. We're looking like zombies. But the end is here, and the jury has made a decision. So I think we could just go straight into. We have a final words in the end, but we can now just jump straight into the prizes for every challenge. Let's start with Corentix. So actually, do you want to announce them yourself, or should I?
I can show you.
Okay. So yes, let's applause. Yes, please. Oh. Thank you. I need motivation because I'm really, really tired. So, okay, better now. For the Corentix challenge, we start from below. The third prize, unfortunately, guys, I have to say, third and second prize, it's just some mugs, like some souvenir. Yeah! some souvenir from PolyHACK, and then, well, as you know, the first prize is the first prize. So for the third prize of Corentix, we got Team 4. Please, Team 4, come to the stage to take your souvenir. Sophie, please. Yes. Yes, and if you want to say a couple of words, yeah, you can say here. No, come here. Where's the rest of your team? You're only two?
Yeah, only two.
Only two. Cool. So, yeah, Sophie. So we got you 4 mugs because double the mugs. Do you want to say anything?
No, I mean, thank you for the mugs.
Thanks for the challenge.
Yeah. Big round of applause for Team 4. All right. Next on the list, we have Team 15 for the second prize. Please, Team 15, come get your prize. And we have for Team 15 another set of mugs of PolyHACK. Where? Woo! All right.
Guys, come. Some words from team representative.
Do you want to thank anybody in special, like your fourth member?
Thanks for the nice work with my group.
All right. Did you like the enjoy the experience? Great. Thank you. All right, big round. And now the big prize. Yes. Let's have Michael announce the first prize.
Maybe you want to explain first why?
Yeah, I think I will explain it. Okay, let's get to the winners. It was, I first have to say, it was a super difficult decision. We really talked a lot about the final winners. And the team that really convinced us, because they really looked at the problem from A to Z, they found solutions, they analyzed the data quite well and really worked like a startup, I have to say. They prototyped, they developed a minimal viable product that can already be used to get useful decisions. And that's really, I think, was the convincing factor. Even though we thought like the team in the second place already also had a very solid model. So I think we would have liked to fuse maybe second place and first place together. But in the end, there was now just one winner. And that winner is team number 19. Congratulations. 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 Great work. Yeah, thank you.
Okay, are we taking pictures?
Yeah, maybe you can group together.
Okay.
Yes. Let's take it. Okay. Cheese, PolyHACK. Is that it? All right. Okay. And now maybe if the winners want to say some words about your experience, how you found it, the challenge, how you liked it, what would you do better, maybe more difficult.
You started.
Okay. Well, I just want to say a few words of thank you. It was a great pleasure working on this challenge. I think at least I had a lot of fun, and I think I can speak in the name of a lot of people here. So thanks a lot for Currentix for providing this challenge, for supporting us within Q&A, and yeah, providing such an interesting challenge. Thanks a lot for like all the organizers here who organized all the food, all the logistics, all the teams, all the challengers, staying up late the whole night, and being there for us to support us, make sure we feel great, we have food. And yeah, I think we had a lot of fun, and like big applause to Currentix, SBB, and all the organizers.
Okay. Also, thanks a lot, and also to the teams who were not on stage now. I just wanted to thank you for the enthusiasm to work on this challenge. And we would really like to continue a bit this journey and get your inputs. And we would like to invite all the Currentix teams for a little apero, a drink, and maybe a pizza or something else at the Currentix offices in the next few weeks. So we'll send out an email and would like to see you there. Maybe there's opportunities to discuss those challenges further. Thanks a lot.
Perfect. And now we move on to the SBB challenge. So for the third prize, yes. Oh yeah, quiet. Actually, no, not quiet. Woo! SBB challenge. So for the SBB challenge, third prize, we got Team 5. Woo! And for Team 5, we have Max. But also the recognition of being the third team. I mean, the winning team. So, come here. Come on. Come here and, yeah. Anything you want to share of your experience?
Thanks a lot for the whole experience and the team for organizing everything.
All right. It was. Okay, big round of applause. All right, thank you guys. Now, for the second prize, we got something else. You'll see in a minute. And we got Team 17. Woo! So, you can give the... And now we got something different from SBB. We got 2 bottles and 2 notebooks. So you have to choose who gets which. Guys, come here. Guys, we're live stream. Come here. In front of the camera. Yes. Who wants what? Hard choice. Upa, yes, good. All right, and then anything you want to share? Come on.
That's the best day of my life.
Wow! Big declarations! So you're happy. And you're probably also tired, right? All right, great. Thank you very much. And now, thank you guys. And now for the first prize, we invite Christoph. First prize! Woo!
So thank you very much. I'm very impressed. It was hard to make a decision, but it's part of a game. You are all winners, really. I'm sure you take away in experience, insights, and I think also a lot of fun. I encourage you really to push away your ideas, your concepts, and use SBB and public transport. Thank you very much for your ideas, concept and all. And we are not a TV show, so I make it short. The winner is Team 3. Here you go. You're the winner because your idea, your concept is innovative, it's simple, it's personal. So thank you.
Okay, now I give the mic to you if you want to share any words.
I have something very important. I lied to you. Like, actually, I'm not going back to the Chaos City tonight. It's just like, just no information. But yeah, it was a very nice challenge. Thank you all for organization and really enjoy it as well.
Yeah, thank you to everyone for organizing this.
Yeah, thank you.
Thank you.
All right, thank you very much. So with this, we might maybe like to give some closing statements. We would like to thank our sponsors, our main sponsor, gold sponsor, who without which it would have really been impossible, really. SBV, who provided the main challenge. And we also had Zurich Tourism. We also had Zurich Tourism sponsors us, SkyCell, and we also got sponsored pizzas, as you know, by Domino's. You guys ate a lot of pizza. And we got some beers from Hot Pub. And maybe we need to have some, what? And Corentix, who provided the best challenge ever, obviously. And with this, I would like to pass the mic to Nero to say to talk on behalf of Telejob.
Thank you, Miguel. I think there's like, from Telejob's side, also like preparation time. Miguel knows it, almost half a year. And then also the fusion this year, newly with Neo. I think Amir will say something from Neo's side. But for us, from our side, it was also quite intensive, I would say, the last 24 hours, but also the time before. And I think we were also strict with you, like keeping the deadlines, keeping the masks on. And I hope you also enjoyed it with our strictness. We enjoyed it from our point of view. And seeing what you delivered today is like amazing. Also, I think the feedback from the different companies were also, I think, quite positive. So hope that you keep it up, also in the sake of climate change, that really changed the future. And I also want to keep it shorted here. So on behalf of Telejob, you've seen a lot of members today here as well, and yesterday. So it was really enjoyable with you, and yeah, see you around hopefully soon, huh?
Also from side of Neo Network, I would like to also to keep it very short. So thank you everyone for taking part to this challenge. Thanks to all the sponsors being here on a Sunday. So I guess this is not it's really valuable to have you here. I hope you all enjoyed it. I've seen smiling faces, so I guess that's a good sign. I also want to especially thank the jury. So we have something very, very small for you guys prepared. We'll hand it over after closing the sessions. Maybe also, I would like to thank the whole organization team, also the camera team, everyone who participated, and looking forward to the next challenge, maybe as well with Telejob next year. So see you around. Grab a beer upstairs if you want to stay. Feel free to do whatever on your Sunday evening, and happy Halloween.
And now a more practical thing, please try to help us a little bit to keep the workstations clean. So if you can just put everything in the trash and try to, all right, that would be great. Thank you. Also, if everybody who wants to stay and help us clean that, well, that's absolutely welcome too. All right, thank you.